right, hello everybody. Welcome to our next unit, our next day in calculus. All right, so we are officially starting Calculus BC material, which is awesome. Okay, we're in that Calc 2 portion of calculus of material. Okay, and this is Unit 7. Okay, so this is called Techniques of Integration. Okay, this whole unit is going to be about all the more advanced ways to integrate. Okay, so in Calc AB we learned certain rules, some certain definitions. We learned use substitution, but now we're going to expand that list a little bit. And the lesson we're going to talk about today, the first method that we're going to learn in this unit is something called integration by parts. One of the more common definitions in Calc BC that we use. Okay, we use this often, and we should be able to recognize the situation. And I think this is a good lesson to start with because it's not the most terrible thing in the world to do. Okay? All right, so let's read through this. We use substitution to integrate chain rule. Okay? So whenever we did use substitution, that was pretty much integrating chain rule. Okay? We used integration by parts, our new definition today, to undo the product rule. Okay, so again, we know how to do chain rule. That's integration, or that's substitution. Use substitution. And now we're going to learn how to undo the product rule using integration by parts. So this whole definition today comes from the product rule. Okay, so let's recall what the product rule was. So this whole first slide is just us explaining where the formula comes from. Okay. So first of all, by the definition of the product rule, the derivative of f times g is just simply derivative of the first, keep the second the same, plus keep the first the same, derivative of the second. Okay, that's just product rule. Okay. And it's from this product rule that we get this new definition for integration. So let's think about this. What if I said, okay, well, let's integrate everything. Let's work backwards. Let's integrate, integrate, integrate. Okay? All right, well, just bear with me here. The integration of the derivative is just what I'm originally left with, right? So this is f of x, gx equals. And then I'm just going to simply write out this line. Okay. Okay. Now, whenever I'm doing integration by parts, it's actually this piece of the function they're going to be asking you to find. Okay, I know that sounds weird, but this is where the formula comes from. So let's shoot this over to the other side. Let's get this by itself. And how we're going to do that is we're simply just going to subtract this integral over to the other side. So I'm going to rewrite it this way. We're going to have the integration of f of x, g prime of x, which is just this quantity here, is equal to f of x, g of x, minus the integral of, and I'm gonna rewrite this. Instead of f prime g of x, I'm going to say g of x, f prime of x. Okay. So all I did between these two lines was just isolate this quantity. See, this is what they're going to be asking you to find. And it's just a manipulation of the product rule. Okay? So just to build up to this formula, I'm gonna use the notation that the formula uses. So instead of f of g, let's just say, okay, let u be f of x, not from u substitution, but just a different quantity. And we're going to let v be g of x. Okay. Now in this next line, all I'm going to do is just substitute all of my f's with u's and all of my g's with v's. So simply put, this is the integration of, instead of f, it's u. Instead of g prime, it's v prime. Is equal to f and g, that's u times v, minus the integration of, instead of g, we're going to say v, and instead of f prime, we're going to say u prime. Okay? So all I did was just substitute in those values. All right, now, instead of saying v prime and u prime, all I'm going to do is going to say integration of u instead of v prime. That's the same thing as saying dv is equal to uv minus the integration of v, and instead of u prime, I'm going to say du. All righty. Well, all I did was just manipulate the product rule a little bit, and I used u and v instead of g and f like we're used to using. Now, this right here is integration by parts. Okay? This is integration by parts. If all that argument beforehand just you didn't like it, that's whatever, as long as you know this formula. Okay? This is what we're going to be asked to find. Now, this is something that we won't be able to can't take the integral of. But all of this, we can take the integral. So we're going to be given the left side, and we're going to set it up as the right side and integrate. Okay? So the integration of u dv is simply put, you're going to memorize this right half as uv minus the integration of v du. That's it. Okay? And here it is, summarized for you. The integration of u dv is equal to uv minus the integration of v du. Okay? Now, beforehand, so we're about to do an example. Beforehand, I'm going to give you a list later on throughout the unit. But right now, we have a list of strategies to try with integration. I just want to kind of refresh ourselves on those. So like usually I would just suggest this order of steps to try with integration. Like for instance, just try to straight up take the antiderivative. All right? Antiderivative is all of our rules. So like power rule or working backwards from trig, those types of basic rules. So try a simple antiderivative. That's straightforward. Number two, I would suggest trying to simplify. Okay, so to try to reduce down the function, try to substitute an identity for trig, something that you can simplify down. Maybe do conjugate pairs. Just any way we've learned to simplify. And none of that works. Remember that for the other way was chain rule. We undid that doing use substitution. Okay? Those are really the only three that we've really kind of categorized for integration. And if you can't do any of these, then the next part that we're putting on our list is integration by parts. Okay, so that's kind of the next part I'm putting on my list. Now the idea is to recognize what your u equation is and what your v equation is, your u and your dv. Okay, the dv is we want, that's what our dx is going to be associated with. So for instance, in this case here, we have to figure out what our u is and what our dv is. So if it's set up like this, u dv, let's just try this. Let's say that x, because this is x times cosine of x dx. We're undoing a product rule here. Okay? Let's say that, for instance, x is u. Okay? And we'll make cosine x dx our dv. Okay? So let's just simply write it exactly like it is right here. We'll say that our u is x, and our cosine x dx, that's our dv. Okay? Well, this is how I always tell students to set it up. Okay? So we got our u equation, we got our dv equation. I'm going to need to know my du equation, and I'm going to need to know my v equation. So I always set it up in this order to do a little shortcut rule here. All right, so I'll let u be x, and I'll let dv be cosine x dx. If you have a dv, you're going to have a dx one. All right, then du is the derivative of u, so the derivative of x is 1 dx. So I'm just going to write dx. And if dv is the cosine of x dx, v is the integral of that. So the integral of cosine, if we're working backwards, is sine of x. And since we're integrating, we lose the dx. Okay. So once we have our u, our dv, our du, and our v, all we have to do is set it up in this equation. uv minus the integration of v du. And if I set it up this way, I always tell students to do a little z thing, and that's the order we go in. U dv is equal to, and I say from u v minus the integration of v du. That's the, I just followed the line there. So the integration of u dv is u v minus the integration of v du. I don't know, just sometimes that helps students if they draw a zigzag to connect the dots here. But again, this integral is equal to u x v, or sine of x, minus the integration of v, which is sine of x, and du, which is dx. So uv minus the integration of v du. You're going to say that a lot, and you're going to be doing it a lot. Okay. All right, so that's pretty simple. Like, so we already got x sine of x, and then the integral of sine of x. Well, we know that's going to be. Let's see, the integral of sine of x is negative cosine of x, so it's going to be plus instead of negative cosine of x. Let's see. Okay, so we take something. So we look up here. We took this x cosine of x. We can't simplify it. We can't do u substitution. U substitution wouldn't work. The only thing left to do, especially since we have two things multiplying together, is to do integration by parts. Okay. Now, it's not always, so we're going to have something always multiply together, right? But it's not always going to be u first and dv second. Sometimes it's the reverse order. So we're always going to be able to identify which is which. Okay? Well, this next slide kind of helps us with that. Okay? The key is to figure out which one's going to be u and which one's going to be dv. And it's not the biggest deal if you mess up, because if you mess up, then it's not going to work. Okay? So then you have no choice but to go back and switch the order. But here's some tips to make sure you get the right thing. Okay? Choose u so that when you take the derivative, it's simpler. Okay? You don't want to have a derivative that's more complicated. And you want to choose dv so that the integral can be evaluated. Don't choose something that you can't take the integral of for dv. And this is one of my biggest things I love telling students. Need help finding u? Use, I call it liate. Liate, it's an acronym, liate. Whichever one of these comes first is usually what u is. Okay, so liate. So logarithm is usually your first that you would choose for u. If not that, then an inverse trig. If not that, an algebraic term like a polynomial, x squared or something. Trigonometric, so that would be like your sine slash cosine, or just a basic trig. And then the very last thing that would probably be u would be an exponential. Okay, so this isn't golden, but works like 9 out of 10 times. Okay. So, liate, keep that in mind. Let's try another example. Okay. So, remember our formula. The integration of u dv is equal to uv minus the integration of v du. So, like, I want us to commit this to memory. All right? So, the idea is to recognize what u and dv are. Okay, so I always tell students, we got to know what a u is. We got to know what dv is. We're going to figure out what du is. We're going to figure out what v is. And then it's just plugging it into a formula. Okay. Now, remember liate. Okay, we got two functions to decide between which one's going to be u and which one's going to be dv. We got an x and we got an e to the x. Okay. So go down the list to figure out which one u is going to be. Is there a log equation? No. Is there an inverse trig equation? No. Is there an algebraic term? Yes. Okay, that's the first function that we come across is x. X is an algebraic term. So how about I let u be x, and I'm going to let dv be the rest. It's going to be ex dx. Okay. All right, so if u is x, then du is just 1, or 1 dx. And the integration of e to the x dx is just e to the x without the dx. You integrate, dx goes away. All right, and like I said, I always tell students, like, draw your little zigzag, and that just helps me remember the order. So I know that it's going to be u v minus the integration of v du. So x e to the x minus the integration of e to the x dx. So this integral is the same thing as saying this right here. And when I do that, it's like I'm almost kind of like halfway integrated it. Like I got this piece already done. Now all I got to do is just integrate e to the x. And that's pretty simple, right? The integration of e to the x is just e to the x plus c. Ta-da! There you go. Okay, what about ln of x dx? Okay, there is nothing being multiplied here. There is nothing being multiplied here. It's just ln of x and just dx. It's only one function, but that doesn't mean we can't use integration by parts. It's funny because we know what the derivative of ln of x is. It's 1 over x, but we've never discussed what the integral of ln of x is. That's because it requires integration by parts. All right, well, let's set it up. We need to know a u. We need to know a dv. That's what starts. So then we also need to know du and then a v. Okay. All right. Well, here's the thing. So since there's only one function, there's only one thing that u could be. In this case, the one thing that u could be is just the ln of x. That's the only thing u can be. Meaning that the only thing that dv can be is just that dx that's left over. Okay. So even though nothing's being multiplied together, you can still have a dv be dx. You can still have a u be whatever the function is. Okay. All right, so then the derivative of ln of x is 1 over x dx. And the integration of dx is actually just x, right? Because think about it, this is actually saying 1 dx, if you want to think of it that way. And the integration of 1 is just x. That's the way I like to think about it. Really, this is the ln of x times 1 dx. All right, and we do our little zigzag, and I'm going to say u v minus the integration of v du. So and let me explain how it works with definite integrals. So don't do the definite integral until the very end of the problem. That's my suggestion. So this is equal to uv, or x ln of x, minus the integration of, okay, and in this case it's v du. So that's x, and then du is 1 over x dx. Okay, 1 over x dx. Now the cool thing is that 1 over x and x cancels out, so really I'm left with 1 dx. So this is equal to x ln of x minus, okay, and the integration of 1 dx is just x. And because there was numbers here, 1 to 3, we are evaluating this from 1 to 3. Now the reason I told you to hold off writing the numbers in until the end is because I didn't want you to make this mistake. You're not just plugging 1 and 3 into x, you're plugging 1 and 3 into the entire quantity, okay? Because this entire quantity is technically the integral of ln of x dx. We just did it kind of in pieces. Like this was the first integral, and then we just did the second integral right here. So you got to plug the 1 and the 3 in for all of the values, not just the integral of that last part. Okay? So just make sure you just wait till the very end. Whenever you're done integrating, then substitute in your bounds. So this will be 3 ln of 3 minus 3 minus, and then 1 plugged in, 1 ln of 1 minus 1. I think I put an extra parenthesis. Oh well. The ln of 1 is actually 0. That goes away. So you could just say 3 ln of 3, and then negative 3 minus negative 1 is negative 2. You could do that. Or you could have just left it simplified. Either one's up to you. Okay. All right, I got like, I don't know, maybe 3 or 4 more, but we'll just see what we get done. All right, again, the integration of tan inverse of x dx. Now, It doesn't look like we're multiplying anything together, but that doesn't mean we can't do integration of parts. We know what the derivative of tan inverse of x is. We know that's 1 over 1 plus x squared, so don't make the mistake to accidentally write the derivative. But if I want to know the integration, okay, well, let's think about this. I mean, if you were approaching this problem right now, I would ask you to go down the list. I mean, try doing u substitution, try simplifying, try doing a basic antiderivative. None of those work. So u substitution is the only thing left. Well, what happens if I do u substitution? U du, dv, and v. Okay. Well, you can think of Liate if you want, but there really is only one function to choose for u, and that's tan inverse of x. dv has to be dx, or if you want to think of it as 1 dx, you can. Okay, so then if I have to find the missing pieces, then the derivative of u, the derivative of tan inverse, is just 1 over x squared plus 1. That's a derivative from a while ago. And the integration of 1 dx is just x. Now remember the formula, it's uv minus the integration of the du. So in this case here, if I did my little zigzag like I like to do, uv would be tan inverse of x times x, or I'm just going to write it as x tan inverse of x, minus the integration of v, which is x, du, which is this quantity. So I'll multiply those together, that's x over x squared plus 1 dx. Okay. Now, we couldn't integrate the first part, but we can integrate this second, x over x squared plus 1. We can integrate that. We can integrate that all day long. Try your other, go down the steps again. See if you can do simplifying or u substitution. In this case, I think u substitution is our best bet. So what I'm going to do is I'm going to say u is equal to, let's try that bottom quantity. Well, x squared plus 1. So then du is equal to 2x dx, or 1/2 du is equal to x dx. And lo and behold, here's the x dx. So if I do u substitution for that second part, dx dx just becomes du, the 1/2 comes out, and I'm left with 1 over u du. So that's u substitution. I plugged this in for u, I plugged this in for du, and the 1/2 came out. And again, we're waiting to do the balance until the very end. So I got x tan inverse of x minus 1/2. The integration of 1 over u we know is ln, absolute value of u. And I'm going to go ahead and plug back in what u was, which was x squared plus 1. Now, instead of saying plus c, right, we're integrating this, if you remember from the very top, we're integrating this from 0 to 1. So now I can plug in my bounds, 0 to 1. Okay, so if you plug 1 into that, that's 1 times tan inverse of 1 minus 1/2 ln absolute value of 1 squared plus 1. So all that. And then minus, if I plug 0 into this, it would be, well, 0 times tan goes away. And then it'll end up being the ln of 1 anyway. So this whole thing actually just goes to 0 if I plug 0 into it. And we can solve this further if you want. I mean, the tan inverse of 1 is pi over 4. But if you left it just the way it was before, you would be fine. This would just be the ln of 2. So you can simplify it down to that if you want. Okay. I'm going to try to get as many as I can in until we run out of time. How about the integration of x cosine of 2x? All right. Well, we got x, and we got cosine of 2x. They're multiplying together. Think of Liate. Oops. Liate. Think of Liate when trying to determine what u is. Okay? We don't have a log. We don't have an inverse tree. We have a regular tree. But we do have an algebraic expression. Okay. So I'm going to let u be x, meaning dv is going to be cosine of 2x dx. So we got to find du, and we got to find v. Well, the integration of x is 1 dx. Or sorry, the derivative of x is 1 dx. Now the integration of cosine 2x, you can do u sub if you want, but remember what I talked about with constants. 2x would just be accounted for as a 1/2 coming out. So I'm just going to simply put this as 1/2. And the integration of cosine 2x, the integration of cosine is sine of 2x. Okay, so there you go. Now, we do our little line here. Okay. We're going to do dv, the integration of u dv, is equal to uv, or x times this quantity, which I'm going to write it in order. I like to write it this way. Constant first, then variable, then trig. But that's up to you. That's just a personal thing. So there's uv minus the integration of v du. So this is v, this is du. I'm going to go ahead and take the 1/2 out as a constant, if that's okay. And I'm left with sine of 2x dx. All right, now you can do u substitution again if you want for that 2x part there. But remember, all it does is just brings a 1/2 out as a constant, and 1/2 times 1/2 is 1/4. So all it is the integration of sine of 2x, integration of sine of 2x, and I don't know why I'm writing integration again. Integration of sine of 2x is cosine of, positive. So yeah, so sine of, okay, it'd be negative cosine, which make this plus, and then cosine of 2x plus. All right. Very good, very good. Okay, I got 2 more, but for the sake of time, I'm just going to do 1 more. I'll do this one, and I'll save this one for class. That's a good one to save for class. Okay. Okie dokie then. Okay, we got 2 things being multiplied together. You can try all your other methods if you want. U sub, simplifying it, what have you, but nothing's going to end up working. So let's think about integration by parts. Think about Liotte. So go down the list. Log. Yes, we do have a log. ln of x is our first equation we come across, a log. So we're going to let u be ln of x. We're going to let dv be the square root of x dx. Okay. And then that would mean du is 1 over x dx. And v is the integration of x to the 1/2 power is x to the 3/2 powers, 2/3. And the dx goes away. And then we can do integration, or uv minus the integration of v du. Okay? So I like to write it in this order. When I do u times v, I like to put my constant first, my variable or my algebraic expression next, and then ln of x minus the integration of v du. So that's v times d u. So I'm going to go ahead and bring the constant out of 2/3. I'm going to go ahead and bring the 2/3 out. And then I'm going to do this over in the scratch work over here. If I do x to the 3/2 power multiplied by 1 over x, it looks like that, right? That's to the first power, or we can say 2 over 2 power. But regardless, 3/2 over x to the first power reduces down to just x to the 1/2 power. So when I multiply all that together, all it is x to the 1/2 power dx left over. Okay. All right. Then I'm left with just 2/3 x to the 3/2 ln of x minus, and then this is going to be 2/3 multiplied by, and the integration of x to the 1/2 power is 2/3 x to the 3/2 power plus c. And I'm cool with you leaving it that way. I guess you can multiply that together if you want, which I'll go ahead and do. That'll be what, 4/9? But I think that's as far as we can take it at that. So the integration of the above is equal to that. All right. Well, we're a little over 30 minutes. Tomorrow we will try this one. And this is a great problem to end on. It's probably the most involved problem on here. But if you want to try this one on your own, it's not hard to identify what U and dV are. But when you get down to uv minus the integration of v du, when you're integrating this part right here, go through your steps again. How am I going to integrate this part right here? U substitution, simplifying, or some other way. Okay? See if you can do this one on your own, and we'll do it in class together. And as always, here's the homework. But good luck. Okay. I'll see you guys.